Welcome to your ACT math videos. So in this set of videos, what you're going to be doing is you're going to be taking the packet that you received in advisory. In each video, we're going to assign you a certain number of problems. You're going to have 8 minutes to finish those problems, and then we're going to take about the next 12 minutes to discuss the answers so you can see the strategies and how to appropriately solve these problems. So in this first video, what you're going to do in that packet, you are going to answer questions 1 through 12. All right, those are the 12 questions that you're going to focus on. So what I want someone to do is make sure there's someone in the room that has a timer. I want you to set the timer for 8 minutes. Pause this video. Take those 8 minutes to solve these 12 questions. After everyone in the room is finished with those 8 minutes, I want you to unpause the video, and then you can continue listening to see the discussion about how to properly solve these problems. Now, you may have felt a little bit rushed in those 8 minutes. So, as you know, there's 60 minutes for 60 questions given to you on the ACT. Now, we gave you 20 or 12 questions to do in 8 minutes. So, you may have felt a little bit rushed because, do the math, that leaves you about a minute per question for the test. However, on these easier topics, it's worth your time to try to go a little bit faster, okay? For these easier ones, save a little bit of time, go faster, because then when you reach the harder ones later on, you can take more time to process through them. So let's jump right in and start working on these problems. Number 1, which of these numbers is not equal to the others? Now, what I will tell you here is it's easier to compare numbers if they're all in the same form. So I'm going to convert all of these to the same form. That means decimals. So the A is fine. A is already given to me in decimal form. For B, to change a percent to a decimal, I'm going to move the decimal point over twice. Put a 0 in there, so 0, 1, 6, same thing. C, in scientific notation, you have a 10 to the negative third. So that means I have to move the decimal place over 3 times. 1, 2, 3. So I have 0.0016. So I'm already pretty convinced C has to be the answer. C has to be the one that's not the same. However, it's always a good idea, check the others still. So 16 divided by 1,000 is 0.016. 16 times 0.001, again 0.016. So in checking the others, we were correct that the answer is C. Number 2, at the beginning of January, Molly had $6,000 in her savings account. In February, she had 25% more than she did in January. And in March, she had 30% more than she did in February. How much more money did Molly have in her savings account in March? So she started with 6,000, and she had 25% more. So we need to multiply that by 1.25. The 0.25 being that 25%, leaving the 1 there to show that we're taking everything we had before and adding on that 25%. So when I type that into my calculator, so in February she had 7,500. Then it says in March she had 30% more than she did in February. So now I take that answer from February, and to add 30% to that, I multiply by 1.30. When I type that into my calculator, I get $9,750, and you can see that matches answer E. Number 3. So here's an order of operations problem, and hopefully you know order of operations. You need to work with PEMDAS, parentheses, exponents, multiplication and division, then addition and subtraction. So the first thing is we need to take care of that exponent. So dealing with that exponent, it's going to give me 5 minus 36 to the negative 3 minus negative 4. So now I need to do the multiplication. The negative 36 times the negative 3. Remember, a negative times a negative is actually positive. Just like subtracting a negative. Those are going to become positive in this next step. So now I'm to the addition and subtraction piece. So now I add all those up. 5 plus 108 plus 4 is going to give me E, 117. Number 4, what is the least common denominator of those three fractions? To find the least common denominator, remember what that means is each piece has to have every piece from the denominators. So what that means is first I'm going to focus on the numbers. So between 2 and 4, I need to find the number that includes both of those. Well, since 2 already goes into 4, that means our common denominator between those two would be 4. With our x's, I see an x squared, and an x. Well, when it comes to those variables, to be in the least common denominator, you're going to need the one with the highest exponent because that x squared has to be accounted for in the common denominator. So that means I need to take the highest power. For the y's, I see a y, and a y squared. Well, that means in that end result, in the denominator that is common to all of them, we need to at least have y squared because that's the only way that we can have that common denominator between them. And then finally, you'll notice that this one has a z in it. And again, in that common denominator, everything must be accounted for. Therefore, the common denominator must have that z, resulting in B, being the ultimate common denominator. Number 5, 6 different marching bands will be participating in a parade. If the local high school's band must march first and the state's professional band must march last, how many different orders can they march in? So we have 6 bands. 1, 2, 3, 4, 5, 6. Now the first spot only has one choice, all right? It has to be that particular band. All right, same thing with the last one. The last one only has one choice. So those are already pretty set in stone. The only thing that's changing are the ones in the middle. So I'm going to go through and I'm going to run through the choices. How many choices do I have for the second band? Well, there's only 4 left to choose from. For the third one, well, now I'm only going to have 3 choices left. Each of them are only playing once, so I only have 3 choices left. 2 choices, and 1 choice. So remember, this is called the fundamental counting principle. You line up all the choices you can make, and then you multiply those choices together to see how many total ways could they have occurred. In this case, the answer is going to be C, 24. Which of the following statements is not true? So notice the not here, that's going to be key. Every one of those statements is going to be true except one of them. So all irrational numbers are real numbers. All prime numbers are whole numbers. All natural numbers are integers. All decimals are rational numbers. All whole numbers are integers. All right. Let's take a look at these individually. A, all irrational numbers are real numbers. Well, everything that we learn about in terms of these subcategories are real numbers. So that is going to be a true statement. In order to be irrational, it's going to have to be real. All prime numbers are whole numbers. Well, think about the definition of prime. We're talking about numbers that can only be divided by 1 and itself. But in that definition, we are always talking about whole numbers. Okay, we're not talking about fractions or decimals or anything like that. So by definition, yes, when we say prime, we are talking about whole numbers. All natural numbers are integers. Now here, remember the natural numbers are the counting numbers in the world. The very first thing that math started with. So is every natural number also an integer? The answer is yes, because integers, the only difference is that they also include 0 and the negatives. I'm going to skip down to E. So E, all whole numbers are integers. Well, whole numbers came right after the idea of natural, when they came with the idea of having nothing, having 0. So yes, those are all integers as well. So now it comes down to decimals. So would you agree? The square root of 3, that creates a decimal. 1.7, blah, 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 keeps going on. So it creates a decimal. However, that is not rational. Remember, it can't be written as a fraction. And therefore, that is going to be our answer. There are decimals that are not rational. Number 7, solving these things. So solving equations. First thing, you need to make sure your variable is on one side. So I'm going to subtract off that 3x from both sides to gather it to one side. Now, I still need to get everything else away from my x. So I'm going to subtract 7 from both sides now. That's going to give me a negative 12. 3/5 of students are in the school orchestra and play the violin. If 2/3 of violin players are girls and 24 girls play the violin, how many students are in the orchestra? All right, so let's work backwards to solve this one. So I'm going to start at the end. If 2/3 of violin players are girls and 24 girls play the violin, how many students are in the orchestra? Well, I'm going to use that, okay? I'm going to say 24, and if I divide that by that 2/3, that's going to give me that there's 36 violin players. If I then take those 36 violin players, because that consists of 3/5 of the student body that's in orchestra, so if I divide by that 3/5, that's going to give me 60 people in the orchestra. Number 9, what is the product of those two numbers written in scientific notation? What I would think is the easiest thing to do for this one, I would just multiply them. When you just multiply them, you get that. So, to get in scientific notation, I need to move the decimal over. So I have a number between 1 and 10, and I moved it over twice. So I'm going to put a 10 to the negative 2 and get that as my answer. A grocery store sells 3 pounds of apples for $6.27. If Maurice goes to the store with $25 and buys 10 pounds of apples, how much money will he have left over? Well, first let's find out how much it costs per pound. So I'm going to divide that to get my cost per pound. When I do that, I get it's $2.09 per pound. So you buy 10 pounds, multiply that by 10, that means you are spending $20.90. Take $25 minus that, and you're going to end up getting $4.10 left over from the money that you brought. Jessica's getting ready for school and needs a pair of socks. In her sock drawer, she has 14 white socks, 10 black socks, and 4 navy socks. If the first sock she pulls out of the drawer is white, what is the probability that the second sock she pulls out will also be white? Well, first we have to look at how many socks she has total. So I'm seeing 28 socks total. Now she's already pulled a sock out of the drawer. So what's the probability the second one will be white? Well, she's down 1 sock now. She only has 27 left to pick from, and she only has 13 white socks left in the drawer. So that's going to be 13 out of 27. What is the median of that number set? Now, the most important thing, remember, when you're finding median, you have to put the numbers in order. So let's really quickly put all of these, oh, I forgot 19, all these numbers in order. And then remember, the median is going to be the exact center of that. So I take off 1 from each side until I get down to the middle. Well, here, Notice I have two numbers in the middle, so I simply take the average of those two numbers. So those are the first 12 problems. Thank you for joining us through these explanations, and look forward to more videos going over some more pieces of this packet.